Yeah, good everyone. So today we'll be looking at another example under armature reaction. The question says a 400 volts 1000 ampere lamp wound DC machine has 10 poles and 860 armature conductors. Calculate the number of conductors in the pole phase to give full compensation if the pole faces cover 70% of pole span. It covers 70% of pole span. Now, our lap wand tells us that our number of parallel parts is what? Number of poles, which is what? 10. Now, they are demanding that for us to give them the value of number of what? Conductors. The number of what? Conductors that is responsible that was put on the face to give a full what? Compensation. Now, what they're asking us here is the extra um tons or the extra tons per pole for compensation compensation. So this is a compensating winding that we're talking about. So our armature reaction, if you're to kind of bring out its other components or use two components, this x and y components, but this is respect to the height, as respect to the width. So if you have to bring out these two components, here is your demagnetizing ampere turns per pole, while here is your cross magnetizing ampere turn per pole. Now, in one of our videos, we say that this can be countered using what? Extra turn. You add extra turn to your poles, to your poles, in order to create more mmf to cancel its effect. For this, we made mention of two counter for it, way of kind of reducing or removing it or neutralizing it. We said the first one was compensating winding. In fact, they have more. We even have, you can also counter it also by also what? Shifting your brush, but mostly used is your compensating winding. Though that one is used in a expensive generators. That one is more expensive because that one requires you to open some holes. Your compensating winding, if this was to be your pole and your armature and another pole, and here is your north and south, your compensating winding requires you to make kind of a hole or a slot here where extra winding again will be fixed. Here you fix another more winding into these holes in order to counter this cross magnetization effect of your armature reaction. So we are asked to get the number of what? Conductors. Now this is given to us as the value for that number of turns or conduct. Let me use turns. Number of turns per pole of compensating winding. This is given to us. This is given to us as now. This is giving this the number of turns per pole for compensating winding is given as your number of what? Armature conductors over 2p. Your p is for what? Number of poles. So if we're to get multiplied by our pole arc over what? Pole pitch. Now this ratio is exactly what this statement covers. The pole face covers 70% of the what? Pole span. So that's exactly what this ratio is going to give us, but we have already been given the value of this ratio already, which is what? 70%. So pole arc over pole pitch is equal to your the part the how will I put it, the face or the part of the post face that was covered by the compensating winding. So imputing our values, we have that Z is what? 860 over 2p. Our p is what? 10. Then this is 70%, so we'll be having 0.7. How we got that is 70 over what? 100. So imputing this in a calculator, we have that our value of extra ton per pole is what? 30.1 tons per pole. So we have gotten the number of what? Conductors that was used in for our compensating winding. Now another thing again that might be asked to you to get in some instances is the 8C, that is the ampere ton per pole produced by this number of tons. So using our value, we have that our 8C per pole of compensating winding is given to us as Z, not Z this time around, but our number of what? Conductors or tons, number of tons multiply, which is what we just got now, multiply by your current all over what? Your number of what? Parallel paths. Now imputing your values here, you have 30.1 times your current being what? 1000 over your number of parallel paths being what? 10. So if this cancels out this, you're left with this times 100, which can also give us, this is 1 and 2. So this is 3010 AC. So this one is not given in the question though, but in case if you're asked to get your 80 per pole for produced by your compensating winding, you simply just multiply your number of turns produced given to the compensating winding to your current all over your number of parallel paths. So that's all for this video. Thank you and God bless you. Please subscribe to the channel. See you in the next video.